look at Unit 8 review sheet. Remember, I'm going to go through and do one of each, and then I'll go back through and finish up. So on this first one, we're not graphing anything. We are just going to identify the parent function, the function equation, and what transformations are being made to this particular function. So if I look at this, I have a 3 inside of my radical, which makes this a cube root. It makes my parent function y equals the cube root of x. And now the transformations that are being done, I have an x minus 5 inside the root, which means you are moving to the right 5 units. And then I have a plus 3 on the outside, which means I'm moving up 3 units. Two and 3 are going to be the same. You just have to determine which parent function you are starting with and then describe the different transformations that are being made. On number 4, you are working backwards. They're giving you the transformations that are being made, and you have to write the equation that matches it. So it's a cube root function, and you are shifting it 5 units to the left, 3 units up, and a vertical stretch of 2. Remember that this is what my generic equation looks like, where h is left and right, k is up and down, and a is a stretch or a shrink. So it says vertical stretch of 2, so I know that that's going to go in place of a. It says I'm shifting to the left 5, which means I'm going to have a plus 5 underneath my radical, and then up 3, so plus 3 at the end to match up with my k. Alright, 5 through 10, you are actually going to be graphing these equations and their transformations. So I'm going to do 5, 7, and 9. Right here we have the square root. I'm going to start with my parent function first. So that is my parent function. Now I'm trying to graph x minus 3 plus 2. The minus 3 on the inside is going to move it to the right 3, and the plus 2 is going to move it up 2. So I'm going to move each of these points, right 3, up 2, right 3, up 2. That one's going to go off. And there is my new graph. The domain of this is going to be from 3 to infinity, and the range is going to be 2 to infinity. Okay. Number 7, we are starting with a cube root function. So again, I'm going to start with my parent function. And then I am doing a transformation of minus 3 plus 4. Minus 3 moving it to the right 3. And plus 4 at the end, I'm going to move it up 4. So I'm going to take each of these points and move it 1, 2, 3, and then up 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 1, 2, 3, 4. And then I know it's going to take on the same shape. So there is my new graph. Domain is negative infinity to infinity. Same with range on that one. Okay, on number 9, we are looking at a cubed or a cubic. So I'm going to start with my parent function, which has the same 3 points as a cube root in the middle, but I know that it goes up and down instead of left and right. On this one, this negative is going to be a reflection over the x-axis, and this minus 2 is going to move everything to the right 2. So this point right here is not affected by stretches or shrinks or reflections, and then I'm going to move it to the right 2. This one is reflected and then moved right 2. This one is reflected and moved right 2. So now I know my graph is going in the opposite direction. Domain is still negative infinity to infinity. Same with range. Okay, 6, 8, and 10 are basically the same as far as which parent function you started with. There's just different transformations that need to be made. Alright, on 11, you are given the graph and you want to write the equation that represents the transformations that are being made. So right here, we are looking at a square root graph. So again, there's my generic formula for that. I need to see if there's a stretch or a shrink, if I've moved it left or right, and if I've moved it up or down. This is my parent function of a square root. So I know that it has moved 1, 2, 3 to the left, and it has moved up 1. I need to see if there's been any stretch or shrink, so I'm going to do that movement to this point, so 1, 2, 3, 1, and I end up exactly where it should. So no stretch or shrink this time, so just a horizontal and vertical change. If I move to the left 3, it's going to be an x plus 3, and then up 1 plus 1 on the outside. Okay. 13 through 18, you are finding the inverse of each equation, which means you are going to be switching the x and y and then solving for y. So I'm going to switch my x and y and then solve for y. The first thing I'm going to do is move my 4. Y is still not by itself. I need to go ahead and divide by 2. Remember that there's a 1 right there. That makes that 1/2 x. 4 divided by 2 is 2. So there is my inverse. The original is a linear, which means my inverse is still going to be a linear. Now here, I have original function of a quadratic, which from all of our practice, we know that the inverse should end up being a square root. First thing I'm going to do is go ahead and make g of x a y. And now switch x and y. So x equals y plus 3 squared plus 8. So I have to get y by itself. First thing I'm going to do is I'm going to go ahead and move this 8 over. Well, right now there's still a squared on the right hand side. So what operation can I do to undo a squared? I'm going to take the square root of both sides. On the left-hand side, I end up with the square root of x minus 8. On the right-hand side, I end up with y plus 3. Y is almost by itself. I need to subtract the 3 from both sides. Remember that the x minus 8 is underneath that square root. When I subtract the 3, it is not going to go inside with that 8. It stays on the outside. Okay, and there is my inverse. 17, we are starting with a cube function, which means our inverse should be a cube root. Okay. So I am going to make h of x y, and now I'm going to switch my x and y. Again, I'm trying to get y by itself, so the first thing I'm going to do is I'm going to go ahead and move the 7. This time I have a cubed, so to get rid of a cubed, I'm going to cube root. So on the left-hand side, I get the cube root of x plus 7, and on the right, I get y. So that is my inverse. 14, 16, and 18 are going to be the same. You are switching x and y and solving for y. 19, we are going to use what we learned last unit for composition of functions to determine if two given equations are in fact inverses. Remember that if they are inverses, the composite take in both directions. So f of g of x and g of f of x both equal x. I can't just work one and decide that it's okay. So I'll do g of f of x first, which is really just saying take g and plug in f. So g is 2 times x, which is now 1/2 x plus 5, and then minus 5. I'm going to distribute through. So 2 times 1/2 x is going to give me x. 2 times 5 is going to give me 10. And then I'm going to subtract 5. So I get x plus 5. Well, even though I've only done one, this one already didn't equal x. So I know that they are not inverses. Okay, let's look over here to number 23. Now we're going to look and see if they are inverses based off of graphing them. These are linear, this is my y-intercept, so I start at 4. And then I have a slope of 2/3 x, which means up 2 to the right 3. I can also go down 2 and back 3 in order to get the line if I don't have enough space on the upper end. So that is my first line. Now I'm going to graph my second line, which has a y-intercept of 4 also, but this time it has a slope of 3/2, so I should be going up 3 to the right 2, but I'm going to go off the graph, so I'm going to go down 3, right 2, down 3, right 2. So this becomes my second line. Right away I can tell that these are not inverses, because we know that graphically, for them to be inverses, they are reflected over the line y equals x, which if I can get this on here, goes right down the middle. Okay. I know that if I fold my graph on that line, for these two to be inverses, they would have to match up. Since they do not, I know that these are not inverses. So let's try this with 26. I'm going to go ahead and put our y equals x on our graph. So we have that line that we should be reflecting over. And now let's look at our functions that we are graphing. So the first one I have x minus 4 cubed plus 2, which means I'm taking the original cubed and moving it to the right 4 and up 2. So there is my original graph. This one I'm taking the cube root, which is the left and right one, and moving it to the right 4 and up 2. So then I'm going to get those points. Even though these do look like they are reflected, they are not reflected across the line y equals x. So again, we have no. All right. On the back, you are simplifying the nth root terms. So I've picked a few of these out to do. Remember, when we have cube roots, we can have negatives. So I'm going to try to break down 343 into its prime factorization. So 343 is divisible, is it divisible by 7? Yes. So divisible by 7, which is giving me 49, which is divisible by 7 and 7. Since it's a cube root, I'm looking for 3 of something. And since it's negative, I know that my answer is going to end up being a negative. Okay. Right over here, I have the square root, which means I'm looking for 2 of something. So I'm going to break 20 down. I have a pair of 2's, and I have x to the 12th, which means I have 12 x's. So if I pair those up, I'm going to have 6 sets of pairs. So coming out is going to be a 2x to the 6th, and anything I didn't circle is going to stay back underneath, so the 5. All right, 30. I have the 5th root of 3125, which just means I'm going to be looking for 5 of something in order to break it down. So 3125 divided by 5 gives me 625. Divided by 5 gives me 125. Divided by 5 gives me 25. 5 and 5. So I have 5 5s. So a 5 is coming out. Okay. Right here, I'm again cube root, so I'm going to break down the 135. It's divisible by 5. So I'm going to get 27, which then I can divide by 3, 3, and 3. So right there, I have 3 3's and a 5. So the 3 is going to come out, but the 5 is going to stay underneath. I have 7 A's. So I have 2 sets with 1 left. And then I have 9 B's. which means I have 3 sets of b's. So 3a squared b cubed, and whatever I didn't circle is going back underneath. So, oops, that's a cube root, and 5a is going back underneath. Okay. 33, we have the cube root of 2x plus 1 to the 6th. Remember, the shortcut tells me that whatever is right here, I can take the exponent underneath and divide it. So 6 divided by 3 gives me 2, which means whatever I have inside there comes out and it's being raised to the power that you get when you divide, so squared. Alright, here I have the square root of 275x squared y. There's a negative on the outside, which means my answer will be negative since it is on the outside. It's fine if it's on the outside. I don't want a negative inside a square root. So I'm going to take the 275 and break it down. So I'm going to divide it by 5, and I'm going to get 55. Divided by 5 is going to give me 11. So I have a pair of 5. I have an x squared and a y. So an x squared is a pair, so an x is coming out. So I have a 5x coming out, but I didn't circle my 11y, so that is going to stay back underneath. Alright, that is one of every single type, so now I'm going to go back through and work through the rest. If you want to stop here, you're more than welcome to, or you can continue watching the video. So number 2, this is a square root, and we know that the parent equation is y equals the square root of x. And transformations that are being made, we have a stretch of 4 and a shift 3 units to the right. Okay. All right, number 3. This is a cubic, and my parent function is y equals x cubed. My transformations on this one, I have a negative, which is a reflection over the x-axis, and a shift left 4 units. Okay. Alright, so those are my verbal descriptions of the different transformations that occur. So now let's do 6, 8, and 10, where we are actually going to graph them. Again, I'm going to start with my parent function. I did it over here. You do not have to start with your parent function. It is up to you. This time, we are going to reflect over the x-axis and stretch by 2 and shift to the left 3. I always start with this point right here because shifts and stretches reflections and stretches or shrinks don't affect the origin point, so I'm just going to move it to the back 3. This point right here, I'm going to reflect and I'm going to stretch by 2, then I'm going to move it to the left 3. Okay. Same thing here, I'm going to reflect, stretch by 2, and move it back 3. So here is my new equation. This time my domain is from -3 to infinity. And my range is actually -infinity to 0 this time since it was reflected. Okay. 8, again, we have our cube roots. I'm going to plot my original. Remember, this one goes left and right versus a cubic, which goes up and down. So I'm going to stretch by 2 and move down 4. Again, start at your middle because stretches don't affect it, so I'm going to move it down 4. At this point right here, if I stretch it by 2 and then move it 1, 2, 3, 4, this one's going to go off our graph. So if I stretch by 2, then go down 1, 2, 3, 4, I'm going to end up on the other graph. And then I know the overall shape. Domain and range does not change. -infinity to negative infinity to infinity. Okay. Right here I'm starting with the cube. So now I'm going up and down. No stretch or shrink on this one. We are just moving it to the left 4 and down 1. Starting at my middle point, left 4, down 1. And then I'm going to do the same to my other 2 points and fill in my graph Again, domain and range don't change on these, negative infinity to infinity. All right. Okay, on number 12, we're going to write the equation. We know it's a cube root because it's going left and right. So here is what I have. If I look at my original, we can find that middle point on our graph, which is going to be right here. So if I take this, I had to move back 2 and down 1. So I moved left 2 and down 1. So that gives me h and k. But now I need to find where these second points are, and if I look, they're right here, which typically from there it's only a change of 1, but this is a change of 3, which is going to give me an a value of 3. So 3, and then my cube root of x plus 2 and minus 1. Okay? Alright, on 14, 16, and 18, we are switching x and y and finding our inverses. So first thing I'm going to do is make f of x, y. And now switch. I need to get y by itself. So right now we are multiplying by 6 and dividing by 5. Or we could just say we're multiplying by 6/5, which, to get rid of, I would divide by 6/5. But we know that dividing by a fraction is the same as multiplying by its reciprocal. So over here, it gets simplified out. And on the left-hand side, I get 5/6x. Alright, on 16, I'm going to switch my x and y. And now I'm going to solve for y. So the first thing I'm going to do is I'm going to move the 1 over. And now I'm going to divide by 3. But I still have this squared on y, so I'm going to square root both sides. So on the left-hand side, I'm going to end up with the square root of x plus 1 over 3. And on the right, I get my y by itself. Alright, 18. We are going to make f of x, y first. And then we are going to switch our x and y. And now solve for y. So to get rid of a cubed, we are going to cube root both sides. So on the left, I'm going to end up with the cube root of x, and on the y, I'm going to end up with, on the right, I'm going to end up with y minus 2. Y is still not by itself, so I'm going to add the 2 to both sides, and I'm going to get the cube root of x and a plus 2 on the outside. Again, we're going to use composites to determine whether or not we have inverses. So I have to do f of g of x and g of f of x. So if I start with f of g, it means I'm substituting this into my function. So I'm going to get the square root of x plus 3 minus 3 squared. Well, if I have the square root of x and then plus 3 minus 3, these are going to simplify out. So I'm going to end up with the square root of x squared, which is x. So one of them has worked so far. That does not give me enough information to be able to say, yes, I have to do the other one too. So I still have to do g of f of x. Okay. I'm going to squeeze this in. So that's really saying g of, and let's plug x minus 3 squared into our function. So I have the square root of x minus 3 squared plus 3, which a square root of a squared is going to end up with x minus 3 and then plus 3. So these go away, so I get x. So this one is yes. those two are in fact inverses of each other because on both composites I ended up with x. 21 and 22 are the same thing, so we are going to plug them in. Oops, sorry, you can't even see them. We're going to plug them in to see if we get x, so that they are or are not inverses. Remember, we have to do both, so we'll start with f of g of x. So I'm going to plug 1/4 x minus 2 into f. So I have 4 times 1/4 x minus 2, and then plus 8. So now distribute. So 4 times 1/4 x is going to give me an x. 4 times a negative 2 is going to give me a negative 8. And then I still have plus 8. So those reduce out, and I get x. Half of it's good. Now let's do the other way. So let's do g of f of x. So I'm going to do g of 4x plus 8. So 1/4 times 4x plus 8, and then minus 2. Distribute your 1/4 through. So 1/4 times 4x is going to give me x. 1/4 times 8 is really saying 8 divided by 4, which gives me 2. And then minus 2, so I get x. So yes, these two are inverses because both composites worked. Okay. Let's look at 22. So again, f of g of x. So I'm going to take f and I'm going to plug in x minus 2 cubed. I'm going to get the cube root of x minus 2 cubed and then minus 2. So cube root of x minus 2 cubed is just going to give me x minus 2, and then minus another 2. I'm going to get x minus 4, so no. Alright, 24. I have two functions and I'm trying to determine whether or not they are inverses based off of the graph. So the first thing I'm going to do is I'm going to go ahead and put that line y equals x on my graph so that I can tell whether or not these are reflected over that line. Okay, so there is my y equals x. And now I'm going to graph my two equations and see if they are in fact reflected. X cubed minus 3 is taking the up and down and moving it down 3. And my second equation is the cube root of x plus 3, which is taking the cube root and moving it to the left 3. So if I look at this, and if I were to fold my graph on that line, y equals x, would these match up? Yes. So these are, in fact, inverses of each other. Okay. We got one more like this, so let's go ahead and draw in our y equals x. Okay. And now let's graph our two equations. So I have two linears again. So x plus 5 means I start at a y-intercept of 5 and I have a slope of 1. So there is my first graph. My second graph, I have a y-intercept of negative 5 and a slope of 1. Here's my second graph. If I folded along the line y equals x, would these two match up? Yes. So they are in fact inverses. Alright, on the back we just have a few to finish up of simplifying the nth root. So cube root, which means I'm looking for sets of 3. So I'm going to take 192 and break it down. Alright, so I'm looking for sets of 3. So there's a set of 3, and there's a set of 3. So I've got a 2 and a 2. Here's where we're going to use our shortcut. I can take the 9 and divide it by 3. That means I have 3 sets of x's. If I take the 6 and divide it by 3, I have 2 sets of y's. So 4 x cubed y squared is coming out. and I didn't bring out the 3, and I didn't circle it. Okay. 31 is the cube root of 40, so I'm going to break down 40. And again, since it's a cube root, I'm looking for sets of 3. So a 2 is coming out. I didn't circle the 5. So that 5 is going back underneath. And the last one, number 34, I have a 4th root. And this whole thing is inside parentheses raised to the 12. So I can use my shortcut. I'm going to do 12 divided by 4, which means whatever I had inside is being raised to the power that I get when I do 12 divided by 4, so 3. I can leave it like that, or I can actually say, well, that's 3 cubed, so 3 times 3 times 3 is 27, and x squared cubed gives me an x to the 6. Okay? Same thing with 33. If you want to FOIL that out, you can. However, leaving it like that is a perfectly acceptable answer. All right, that is your review.